At a supply level, many of us are using AI to automate non-destructive inspections like ultrasonic scans, which saves times and improves the accuracy. So adoption has already started. We'll see it expand rapidly. My belief is that AI is not here to replace people, but to replace repetitive low-value tasks. Aerospace will always need skilled engineers, inspectors, and operators because of the complexity, the regulations, and the safety requirements.
Welcome everyone to today's session. I'm very excited to introduce our guest Satish Verenkar, a seasoned project manager with over 16 years of experience in aerospace, defense, and composite manufacturing. He has worked on major programs with Airbus, Boeing, and defense projects, managed large-scale initiatives, set up advanced manufacturing lines, and been deeply involved in process improvements, QMS, and AS9100 compliance. Today, he will be sharing his perspective on how artificial intelligence is starting to transform the world of composite manufacturing. Satish, thank you for joining us. Before we dive into artificial intelligence, could you please start by telling us a bit about your professional journey and how you came into the aerospace and composite industry? Over to you.
Thank you, Dr. Dilshad. Thank you for the introduction. It's really a pleasure to be here. My journey in aerospace and defense has been over 16 years now, and I've been fortunate to work on major programs with Airbus, Boeing, and several defense projects where composites play a central role. Over the years, I've had the opportunity to contribute across the full cycle, from design to costing and development to tooling, production, operation management. I've also been closely involved in continuous improvements, applying Lean Six Sigma and strengthening AS9100 quality systems. I still see myself as a learner, but what I have observed is that while composites are shaping the future of aerospace, they also bring unique challenges. And this is where I believe AI can play a transformative role.
Thank you. And you have spent many years working with composites in aerospace programs, and you have seen both the opportunities and the difficulties. In your opinion, may I know why this artificial intelligence is becoming such an important topic now, particularly in relation to composite and aerospace manufacturing industry?
Great question, Dr. Dilshad. Composites are unlike metals, where their performance depends on so many variables, like ply orientation, then there's resin content, curing, and environmental conditions. Traditionally, we have relied on manual inspections and manual expertise to ensure quality. But this often means that we discover problems only after the part is made. AI changes that. It gives us the ability to predict and prevent issues before they even happen, optimize processes in real time, dive towards what we often call a zero defect manufacturing. That's why AI is not just a buzzword anymore. It's becoming a necessity.
Thank you. You mentioned challenges. Could you expand a bit more on what some of the biggest challenges in composite manufacturing industry is facing today, and especially in aerospace and defense applications?
Absolutely. Some of the key challenges are porosity, voids, delamination, fiber misalignment. This may sound small, but in aerospace, even the smallest defect can compromise on safety. On top of that, composites are very sensitive to changes in process, where a slight variation in autoclave temperature or vacuum pressure can result in scrap. This unpredictability is costly and time consuming. AI offers us a way to bring more control, consistency, and predictability to those complex processes.
Thank you. We hear a lot about AI implementation in industries like IT or healthcare, but not as much in aerospace composites. As company are companies in aerospace already beginning to implement AI in their processes, and if so, how?
Yes, they have. While aerospace seems to be a very conservative industry, both OEMs and Taiwan suppliers have started pilots. For example, Airbus and Boeing are using AI-driven analytics for predictive maintenance, process optimizations. Uh, Defense programs are investing in digital twins to stimulate curing and structural performance. At a supply level, many of us are using AI to automate non-destructive inspections like ultrasonic scans, which saves times and improves the accuracy. So adoption has already started. We'll see it expand rapidly.
Could you give us some practical examples of how AI is being applied specifically in composite manufacturing today?
There are a few areas that stand out, like NDI automation, where AI tools can scan thousands of ultrasonic images and highlight potential defects much faster than humans. Cure cycle optimization, where AI-based digital twins can shorten autoclave times while maintaining quality. Then defect prediction, by training on historical NCRs, that's the non-conformance reports. AI can predict the risks like porosity at specific bond lines. Then even the supply chain, where AI is being used to forecast prepaid demand and monitor supply quality trends. These are just not future concepts. They are already being tested in the aerospace programs right now.
Okay. Let's dig a little deeper into the manufacturing process itself. How can AI support areas like autoclave monitoring or digital twins for composites?
AI is a perfect fit here. Take autoclaves, where they generate huge amount of sensor data like temperature, pressure, vacuum, time. This is where AI can analyze this data in real time and flag a cure cycle if it's deviating in a way that might create porosity or delaminations. For digital twins, AI helps stimulate resin flow, stress distribution, heat transfer virtually. So engineers can optimize the process without trial and error. This reduces the cost, time, and the risks.
Inspection and quality control are huge in aerospace, as we are seeing nowadays. And how is AI improving non-destructive testing and overall quality assurance?
Non-destructive inspection is vital, but it's also time intensive. AI can automatically analyze C scan data, CT scans, or X-ray images, and identify defects far more quickly and consistently than a human operator. Instead of spending hours scanning through images, inspectors can focus on validating the AI findings. This not only speeds up the process, but also improves the reliability and reduces subjectivity.
Okay. What about automation in layer? What about earlier in the process, like during the layup stage? Can AI make an impact there as well?
Definitely. Layup is one of the most human dependent steps. AI-powered vision systems, where AI-powered vision systems can guide operators or automated layup machines, making sure the ply orientation is correct, avoiding wrinkles, spotting gaps instantly. In this way, AI acts like a digital supervisor, reducing errors and ensuring consistency in one of the most critical steps of composite manufacturing.
We have spoken a lot about AI on the shop floor, but you also have deep experience in project management, lean engineering methods, and QMS systems. How do you see AI being applied in those areas, and what kind of AI modules are actually being used or could be trained for these applications?
That's a great question, Dr. Dilshad. AI isn't just for machines. It's changing how we manage projects and the quality too. In project management, tools like MS Project or Primera use AI to analyze past schedules and costs to predict delays and optimize resources. For process improvements, AI can track takt times, NCRs, production data to spot bottlenecks, and even stimulate lean improvements. In short, AI modules are trained in the same data we use daily, project records, ERP, MES, and quality logs, but they deliver insights in seconds instead of weeks.
And you are also have a strong experience in QMS and AS9100. How does AI tie into supply chain management and quality systems?
Great point. In QMS and AS9100, AI can check compliance, manage revisions, group NCRs by root cause, learning from the past audit findings. AI can track material shelf life, automatically flag expiring prepreg roles, and forecast material demand more accurately. On the QMS side, AI helps with document control, NCR analysis, and even audit preparations. For example, it can analyze thousands of non-conformance reports, find hidden patterns, and suggest corrective actions. This shifts the organization from being proactive, from being reactive to being proactive. This is what AS9100 aims for.
Thank you, Satish. And you have mentioned how current artificial intelligence modules are being used in composite and QMS. But AI itself is evolving rapidly. And what are some of the new AI models coming up that could really transform aerospace manufacturing and project management in the near future?
That's a very great point. We are moving from simple predictive models to more specialized AI for aerospace. For example, generative AI can suggest optimized layout sequences for tooling designs. Reinforcement learning is being tested to fine-tune autoclave cycles. Vision AI is making defect detection much smarter. We are also seeing language models being trained on AS9100 to act like digital quality engineers. Supply chain AI that predicts shortages or optimizes the prepreg usage. What's exciting is that these models are now being trained in aerospace specific data. So in the next 5 years, they'll be built right into our MES or ERP and QMS systems.
Thank you, Satish. One concern we hear often is whether AI will eventually reduce jobs in aerospace and composite manufacturing. What's your perspective on this?
That's a very valid concern. My belief is that AI is not here to replace people, but to replace repetitive low-value tasks. Aerospace will always need skilled engineers, inspectors, and operators because of the complexity, the regulations, and the safety requirements. What AI does is free up those people from tasks like scanning thousands of NDI images or checking document revisions. Instead, they can focus on problem solving, innovation, and safety. In fact, AI creates new opportunities for upskilling because the industry will need professionals who can manage and interpret these tools. So it's more about transformation than the job loss.
Now, my last question is about the business impact. Like finally, if you look ahead 5 to 10 years from now, how do you see AI shaping the future of aerospace composite manufacturing?
I see us moving towards truly smart factories. Imagine QO cycles automatically adjusting in real time based on AI feedback. Inspection is being fully automated with near zero subjectivity. Supply chains that predict and adapt to risks, and QMS systems that continuously learn and improve. This will mean fewer defects, faster certification cycles, and more cost-effective production. In short, AI will make composites not only more reliable, but also more scalable for aerospace, defense, and beyond.
Thank you, Satish, for sharing these insights. It's clear that AI is going to be a major force in aerospace composites. Thank you for joining this podcast.
Thank you, Dr. Dilshad. I really appreciate your initiative in spreading knowledge about AI in aerospace. I believe AI is the next big thing towards zero defect manufacturing in composites, and conversations like this are exactly what the industry needs.
Thank you.